Electron dot diagrams, also sometimes called Lewis dot structures or Lewis dot diagrams, are a way to show the number of valence electrons that an atom has. Remember that a valence electron is electrons that are found in the outermost shell or energy level. If we take a look at the Bohr diagram for boron, we know that it's going to have 5 protons in its nucleus, and therefore to be electrically neutral, it has to have 5 electrons. We have 2 electrons in the first shell, and in its outermost shell or valence shell, there are 3 electrons. When we're going to draw the electron dot diagram or Lewis dot structure for something like boron, we just simply write the element symbol and then the number of electrons that are found in the valence shell. So I'm going to draw one here, here, and here. It doesn't really matter the position of those. What matters is that there are 3 electrons in that valence shell. So that is how we draw a Lewis dot diagram or electron dot diagram. Now, when we take a look at the number of valence electrons, it's going to correspond to the group number. So if an element is in group number 1, this vertical column right here, it's going to have 1 electron in its outermost shell. If it's in group 2, then it's going to have 2 electrons in its outermost shell. Now, usually when we take a look at the periodic table, sometimes the groups are listed from 1 all the way to 18. If we just take a look at the second digit in that number, that's going to correspond to the number of valence electrons for that element. So in group number 13, sometimes that's called 3a, just taking a look at that second digit, and we know it's going to have 3 electrons in its outermost shell. So anything like boron, aluminum, or gallium, they are all going to have 3 electrons in their outermost valence shell. In group 4a, 4 valence electrons, so on and so forth. So that's how we can figure out the number of valence electrons based on an element's group number.